I got this working. It's okay. So I'm the CTO of Juxt. I have a confession to make. I don't really know what that means. But I can tell you why I'm the CTO. Kind of for me, it started in 1994 or 5. I was living in Manchester, and I used to get my hair cut at Tony and Guy. And when you get your haircut done at Tony and Guy, how much you pay for a haircut depends upon the person cutting your hair. So the cheapest is a stylist, and it goes up to a senior stylist, and then all the way up to art director. And then somewhere I saw on the list technical director. And when I saw technical director, I thought, oh, I'd like to be a technical director. It'd be great. So, and one day I will be. So one way of becoming a technical director is you can get a load of business cards printed with your name on with the word technical director. And so that's what, when we started up Juxt, that's what John and I did. And I was technical director, and John volunteered to be managing director because it kind of went together. And then after we conquered the UK market and John set his sights out west into the US, we felt that those titles weren't really going to be suitable or understood by an American audience. So we decided to then become, John became CEO and I became CTO. So I want to be honest with you, I want to be a good CTO, partly because I want to give this company great technical leadership. Also because I think then I might be in the running for something like a CTO of the Year award. But if I received an award like this, I think that would be substantial recognition, primarily of me, but also to a lesser extent of the great technical work that we do in this company. So Thoughtworks, when we started Juxt, we were inspired by Thoughtworks and a number of other companies. The reason we kind of selected Thoughtworks was because John used to work there. But they were ahead of us. They had a website, so we got a website. They had a blog. We had a blog. They had a radar. So we did a radar. We noticed something that they do really, really well, which we don't do very well, and it is that they spot trends and they put words to those trends. So you have agile or continuous integration, microservices, data mesh, their new one. Yeah, we don't do that. So I think it's really important because when you put a label to things, your audience start to think that you invented it and they start following you. It's a good hack. If you've ever been in a race and you're sort of behind and there's people in front of you and you can run faster and try and catch up, that's one strategy. Or you can just convince everybody that the finishing line is just behind you. Move the finishing line and turn around and then you're in the front. So my word, I've come up with this, is what I think a CTO should do, is come up with words. So I've come up with a couple of words. So these words are atomic architecture. So hands up, show of hands if you went to school. Went to school? Impressive. Okay. Keep your hands up if you saw a diagram at school a bit like this. So this is an atom. If you were to look really closely at an atom, this is what you would see, a kind of a nucleus with some protons and neutrons closely packed together. And flying around the nucleus of an atom are these high energy, you can put your hands down. High energy electrons. So this is kind of what has inspired atomic architecture. So for me, atomic architecture starts with a nucleus. The nucleus is the data and the facts that we record. Okay, this is really important. And I surround this. You can't really, can you see that? We surround that with some protons. Now protons I like to call the form, but the key thing is they're packed tightly into the nucleus. This is where we store our data. This is where we put some governance. And it's important that these things are together because we want this consistency. We'll come to that later. And then we have a lot of really high energy electrons flying around the outside. And these are our applications. So these are stateless. They're ephemeral. They can disappear. They can turn into photons. And so the idea here is that applications are ephemeral. They're quick to make. They can last a few months. They could last a few years. But the data that they access is something that is in the nucleus, tightly packed, and lasts a long time. And I did sort of start going a bit further, probably a bit too far with this whole analogy, and thought, well, you've got code, and it has a relationship to this form, which is in the database. So if you've ever kind of changed a database table column or a field name, you'll notice it has an impact on code. They're almost like the yin and yang of each other. So I thought, oh, well, that could be the electromagnetic force, and then, but went a bit too far. Atomic architecture. So this is actually quite similar to something that us as ClojureScript developers are used to in Reagent. So in Clojure, we have a device called an atom, kind of overloading the word a bit, but and what happens is we start with the state of a system, and we wrap it in this magical thing called an atom. And what that atom allows us to do is record all the history. Well, it actually allows us to make changes to this state atomically, like it's just one thing and then another. We don't see all the little changes. So that's why it's called an atom. But in order to achieve that, it has to store previous versions. So it has a timeline almost. It's really a kind of poor XTDB. And then we surround these atoms with lots and lots of functions. So if you want to make a change to the state of the atom, you send in a function, and then only one function runs at a time, so they're all queued up. So this is hundreds of functions operating on a single data structure. And we know this is good, right? We've heard this before, haven't we? We've heard this. What is it? It's better than, what is it better than?
10 functions.
We need to, yes, what is 10 functions. Yeah, we've got to sort of channel Alan Perlis here. We need to summon here. He said, it is better to have 100 functions operate on one data structure than 10 functions on 10 data structures. And I think if he was alive today, he might say something like, well, we'll see. Right. 1982, 40 years to the day, he said this. So I thought, well, what does it look like to draw 10 functions against 10 data structures? Can you see? You can't really see, but there's 10 functions there and all have their own. What does this look like? Well, it looks like microservices, right? It's microservices. So I think if Alan Perlis was around today, he would say, yes, 100 functions are better than 10 functions on 10 data structures, but he'd also probably say atomic architecture is better than microservices, right? Because to modernize it. This is quite similar to when I sort of drew that thing about microservices, I think this is similar to a diagram I drew about a year ago when we were talking about SaaS products and how companies are rather kind of slaves to all of the SaaS products that they have. But so this is really in the large, that we have companies that have 10 SaaS products working on and the SaaS people own their own databases. So that we've got a sort of 10, and quite, there are sort of 10 examples here. And I just would, this is the opposite of where instead of having 10 SaaS products working on 10 data, you'd actually say, let's the SaaS people come and create the functions, the electrons, and let's bring them into the nucleus. And this was really a point about data sovereignty. Let's companies own their own data. And this is kind of another kind of Alan Perlis kind of reframing. So when I was sort of thinking about this talk a couple of days ago, as you do, you sort of get bored and you go onto Hacker News. And there was this article on Hacker News about separating your billing from entitlements. Yeah, it's probably better with the lights off. Off, yeah. Yeah, that's good. So separating your billing from entitlements. And it got through Hacker News, endorsed by Hacker News as a comment. This article contains really good advice. So this is a very, very, I would say, the way that people build systems together today. So this point is that we're going to separate the entitlement system here from from the billing system. Separation of concerns, what could be wrong with this? So anything that could go, well, when I looked at this, the entitlement definitions here might actually depend on something in the user details. It could be a kind of, if the user is a manager role, or there's going to be something. So there's also this kind of idea that the billing system is, and somehow the user details are going to subscribe to each other, and eventually they're going to get updates. And what we see with architectures like this is that, firstly, you don't know when something goes wrong. If somebody gets billed the wrong thing or they're on the wrong plan, you can't really figure out what happened unless you kind of look at every single database, and they're all in sync, and they're all being updated independently at different times, so it becomes really complex. Another thing that we see is that it's just really, really hard we're moving data all the time, and every time we move data, we get a lag, it becomes laggy, we get latency, and the data becomes stale as it moves. And so if you have bugs in these systems, it's really, really hard to figure out. And this is a source of huge complexity. Now, this is just a very simple diagram. You can see the complexity emerging in this diagram. Imagine if you took this at a vast scale across an organization. Right? This is a really serious problem in our projects and in our system. And it's very, very hard to dig ourselves out of this mess. So this is partly why I think atomic architecture is an important intervention. So here's one particular, or it could be one manifestation of an atomic architecture. You could have a database, I don't know, let's call it X2DB, in the middle. That's your nucleus or your neutrons. And we kind of tend to wrap it in this fortress of authorization and network layer and security, which we call site. And site serves up the resources. It respects the time that is kind of governed by XTDB, and yet it brings the ability to adds form to that time and data. And as we'll see some examples of today, we can be free to write any number of applications. Some of these can be Kotlin applications and servers. It can be it could be written in Electron, let's say, Electron apps like Slack. Wouldn't that be, crazy? TypeScript doesn't matter. The point is, it really doesn't matter. We could say everything has to be written in ClojureScript from now on, but we don't have to win that war, right? And it's this kind of silly war to win because this landscape changes all the time. This is where innovation is happening. You wait, you learn a front-end framework. What will happen in 3 months' time? Obsolete. You'll have to learn something else. So this is sort of similar to so this atomic architecture is really about, if we dig a bit deeper, this time data, John calls storage, I call form and code. That was a joke, by the way, obviously. Time, data, form, and code. So we start with time. This is about wrapping them like an onion, right? Starting with time in the middle, wrapping kind of the red here is meant to be a graphy like red data stuff. Then we got kind of this leafy thing, the form. And then this is a while ago, I was going to sketch this out, and it kind of had this idea of apps sort of making these connections. And I was beginning to think of OAuth 2 and bearer tokens and that sort of thing. So these kind of ideas have been forming for a while. But this is the final slide. And I wanted to say a couple of words about why these layers are separate by plotting them into a square. So down here at this end of the axis, we've got things that are ephemeral, fleeting, things that might only last a few seconds or minutes or hours. And right at the top here, this axis is stuff that lasts forever, right? So this is the longevity, if you like, the longevity or the life cycle axis. This one here is whether something is global or central or everybody has to agree, and stuff on those left is where you're free to disagree. You can have a local interpretation. You can have local rules. Okay? So if we plot the layers on this diagram, you'll find that actually we only want one record of time. We don't want time to be a function of the observer. I mean, I know in physics it is, but we don't want to build data systems that we understand. We only want one observer when we build. Otherwise, things just get crazy complex. Let's just have one observer if we can. If that means we use an event log, we use Kafka event sourcing, if that's the way that we achieve the single ordered view of time, that's what time is. There's just a set of events that you record. Then for data here, data outlives your applications. I mean, it's very, very frustrating when people write an application, a UI, and a back end, and it's all kind of one big thing, and then you actually want the data in the database, but you've got to kind of separate it away from its UI. You want a new, modern UI. It's really frustrating. Much better if they're separate to begin with. It'd be much nicer if we were free to rewrite our applications when they got old, because data lasts for a very long time. Data is very valuable to an organization. So data tends to be things that is up forever, and you tend to want to just record the facts that everybody can read. This happened, this happened, this happened. That's data. You don't want to interpret. Form is where you start bringing your interpretation onto those facts. What you want to do is rip out the facts or filter out the facts that aren't interesting to your context, to your application. And you want to focus in on the facts that are important and shape them in ways that is going to help you deliver a solution for your problem at hand. So form is much more contextual and much more local, okay? But it is evolving, it is more fleeting. You change your interpretation. We change our form in two ways, mostly because our understanding changes, our interpretation evolves, and also because sometimes environmental circumstances, the market changes, and we're forced to change our interpretation and our rules. This is where this is the domain of types and rules. I think tables are an intersection of data and form. And a very easy way of understanding it is data is the rows and form is the columns. And because it's so easy to compose data and form in this way, this is why relational tables in SQL databases and spreadsheets are so powerful and so successful, and they last so long, because they're so simple. They have a very, very easy way of bringing data and form together. But it comes at a cost. The cost you have with database tables is rigidity. The form, because it's a database, the form gets the columns get kind of wired into the table structures, and they can't evolve. They want to, so you've kind of got increased rigidity, so you lose this evolvability, flexibility of form. Conversely, in spreadsheets, something else happens. You get the lovely, fast, quick evolvability of a spreadsheet, but you lose the rigidity, right? You end up with lots of spreadsheets flying around, being emailed to each other. You don't have that centralized consensus for governance, so you lose that, so you get more. But the very, very powerful ideas, right, but they both have trade-offs and expensive ones. So our idea is really at the heart of this is to try and find ways of separating these two concepts. And that's our kind of what we're bringing to the idea of atomic architecture. And finally, code, here today, gone tomorrow sometimes, you know. And this is why it's not really about the languages that we write in, you know, and it's very important that we don't write in languages where we encode and crystallize the form. You know, this is really kind of the problem with big Haskell systems is that the type system is embedded into the code base, right? It wants to be externalized. You want to be able to get your type, your form layer, it really needs to be close to the data. And if it's kind of entangled and wired up into a Haskell code base, it's very hard to untangle it. You can't really, it has to be in a language. This is why I'm much are keen on RDF and JSON schema and those things too, as really the formats for form. Okay, so, well, that's atomic architecture. This is really kind of an experiment, right, to get these ideas, to get this discussed today at the conference. If you think there's things we're wrong about it, come up to me. Let's have some conversations. If you think there's some good points in here or bad points, let's refine it. We can get some blog articles and materials. I hope we can get some marketing around this. And then next year, when the award season comes back, who knows? So, thank you very much. We've got 5 minutes before the break for questions. Or
What does CTO stand for?
I know that, Chief Technology Officer. Or it's Chief Technical Officer. One of the two.
One of the two. Cool.
All right.
So, I have a question. Yeah. Could you go back to your slide, maybe last? Yeah. No, next.
What?
Next. Yeah. So, how time and consensus are linked?
Because the organization only wants you want to have a consensus of what happened when. You don't want a disagreement in the organization of the order of.
That doesn't have anything to do with time.
Well, it has to do with if we've got 3 different systems and we can't agree on whether a person was granted the role to access the document, or they accessed the document before they were granted the role. If you end up with those sort of, then it all breaks down. So that's the point there.
Malcolm.
We've got one with Matt. Yeah. Sorry, Renzo.
Yeah, I wanted to ask if I was wondering, I was trying to form an acronym with time, data, form, and code because I like atomic architecture. At the same time, I like to see T, D, F, and C appearing somehow. So, Tida Foco, Cofo Dati.
If that works in Italian, I'm going to go.
Just a few suggestions, but it just don't sound really like anything nice.
No. No, it's a hard one. I mean, I do like the fact they're all 4 letters. That's kind of the, and there's 4 of them. Like that.
Tida Foco is a bit like I light you up. I burn you.
Oh.
Maybe it's like the 4 times 4 rule. 4 by 4.
4x4, yeah. I mean, if you can, any kind of iconography and ideas for sort of this is probably where we're a bit weak. But Lou, you're in the lead with Lou's done these amazing things on our website where we talk about these, and it was Lou who came up with really this idea of code being these electrons was because we asked Lou to do the code one, and Lou, you ended up with these sort of these sort of rules going around, and that triggered a kind of an idea that was a couple of years ago. So these sort of ideas have kind of been going around. We've been discussing them internally and having fun with them. But I think it's about time. I mean, this has all been really, apart from the website page, this has all been really a kind of in-house discussion. It hasn't really, if we were Thoughtworks, we'd have, we've been winning awards by now, right? So we should be coming out now finally and particularly I think now that Cognitect, who kind of we have been seen them as the the industry leaders, now that sort of they've been acquired and things, it's people look to Jux to come up with these. What's the next? The next wave of ideas is going to take on this kind of closure philosophy, and functional programming I think is has really got this idea of data and code separation. That was what but actually it's more nuanced, it's more refined than that, and maybe we can come up with some refinements that help people. Matt.
I just wondered if ephemeral applications were a hard sell to the rest of the business. People talk often about systems at application level, suggest that they're replacing your applications and it's tricky marketing?
I think old systems tend to stick around forever because they incorporate a lot of this as well as that. But that's one. Also, it does. Old systems will just get abandoned anyway. Right? There's a great website of all the products that Google have abandoned over the years, and it's this like really long list. Eventually, there won't be enough resources to maintain all this stuff. So the fact that things still work, and yeah, it isn't palatable. And absolutely not saying that companies should rewrite their stuff. I mean, I think we're at a kind of industry problem of not having enough developers to support all the stuff that we've created over the years, and that is causing a real crunch. This is a real crisis of finding people to maintain stuff for years and years. So it's not a solution if you believe that we're a very young industry. This isn't a good situation to be saddled with all this legacy so early on. But yeah, this is definitely not an appeal to let's rewrite all the apps again. It's not one of those. Yuri.
Yes, I have a question about this boundary between form and data, because how is it possible to have data without form? So we have tables on this model because we have some minimal interpretation of data, right? And with XTDB, for example, with graph, right? And what is the proper form for this data? So the minimal form which allows us to say, okay, this is data and this is form.
Yeah, I mean, it's a good question. I mean, data and form really are, do need to live together. Where I was first introduced to the idea that they could be separate was when I was working in XML. And there were two XML schema rival technologies at the time, specifications. One that everybody had heard of, W3C schema. And in that language, you would start with your document, which is your data, and you would say, and this is the schema that governs this document, and you would put that in an element at the top level. There was a rival kind of alternative standard called relaxing that was standardized by Oasis, Relax NG, but it's pronounced relaxing. And what they did is say, actually, we're going to bring lots of different schemas, and they say this schema will validate this document, but it would depend on your context. So you might have a big document saying, this is all of the details to do with an e-commerce order, the shipping address, the products, the persons that are ordering, the amount, the quantity. If you're writing a shipping app, the only thing that you really need is the shipping address, the quantity, and the products. If you're creating an accounting app, what might be important to you is the price and the customer, right? And so that was really, I talked about form being a way of shaping or filtering, culling down data that you are not going to be, that would actually get in the way. And it allows you to create a lens where you can sort of look at the data that everybody shows you. You look at it in a certain way, and that means that it's simpler for you to operate. And then your code is ultimately simpler because the form is doing some of the heavy lifting of simplifying as you look at it. Rishikesh.
So, if you take the analogy of an atom further, right? Like interesting things happen when atoms create bonds with other atoms.
Right.
Right.
Yeah.
So, like, could microservices architecture be a representation of that? Like every service is an atom in itself, and then they interact with other microservices by sharing applications, right? By sharing electrons or whatever.
I think that's a really good, yeah. I think that's a good thing about microservices is that it does encourage like these fast. Let's code this thing really quickly in 2 weeks, and let locally people come up with their own applications. Give them the freedom to do so. So almost we're saying here that rather this monolith versus microservices dichotomy, that's a false dichotomy. We're saying actually, when you talk about this stuff, you want a monolith. When you talk about this stuff, you want microservices. And another point you mentioned is about electrons forming bonds with other nuclei. And actually we were talking to a potential client. I won't mention their name, but they were coming from the point of view that they see the kind of the whole banking world or retail banking being broken up into all these different atoms, right? There's an atom for know your customer, an atom for fraud detection, right? There'll be an atom for look at your daily banking account, an atom for that. And then there are atoms that then there are these electrons that all they do is they might sort of take some registration details and create a new bank account, and that's what they do. And then they're sort of fleeting, but they're talking to multiple atoms. So they're sort of electrons in this kind of relationship, but they're stateless, and they can be fleeting. You could lose them without losing the data. You could say, oh, let's rewrite it in Ruby, and you could. So it kind of allows that degree of fluidity. And I think this is what the industry is missing with this whole everybody saying, oh, we're not doing monolith, we're doing modern microservices architecture. I think they're missing this stuff, and they're getting it wrong. Okay, we have overrun. So you want to?
Yeah. Give a round of applause for CTO.